Hello, welcome to Unit 3, Lesson 16. This is the second part of the inequalities that we started. Um, Today, the learning targets are given a two-variable inequality and a graph of the related equation. I can determine which side of the line the solution to the inequality will fall. I can describe the graph that represents the solution to a linear inequality in two variables. So let's start with that. So we are on page 159. So you'll go to page 159 in your book and you can follow along. There is a warm up, page 159. Try this warm up again, page 159. Here's an expression, negative 2x plus 3y. Decide if the values of x and y make the value of the expression less than, greater than, or equal to 6. So you have to decide. So try that, pause. You can figure out if these are less than, greater than, or equal to 6. So hopefully you finished those. I would write the expression negative 2x plus 3y. Anytime I'm going to substitute in, I'm going to change the variables, x and y or whatever they might be, to parentheses. And then I'm going to plug in the values. So each one of these, since I'm doing the exact same expression, I'm going to do the same parentheses every time. It's negative 2x plus 3y. But you see I'm not writing the letters. Every time I say a variable, I do parentheses. So the last one, negative 2x plus 3y. So what is the x in the first one? Remember, it's xy, so 2, and y is 4. Then you're just going to evaluate that. Negative 2 times 2 is negative 4, plus 3 times 4 is 12. Negative 4 and 12 is 8. So is that less than, greater than, or equal to 6? So 8 is greater than. No. Next one, it's 0 and 2 are your x and y. Negative 2 times 0, 3 times 2, 6. 0 plus 6 is 6. So is that less than, greater than, or equal to 6? This one is equal to 6. Negative 1, positive 1. So negative 1, positive 1. Negative times negative is positive, so negative 2 times negative 1 is 2, plus 3 times 1 is 3. 2 plus 3 is 5. And 5 would be less than 6, right? Less than. And finally, negative 2 times negative 2, 3 times 1. Negative 2 times negative 2 is a positive 4. 3 times 1 is 3. 4 plus 3 is 7, which is greater than 6. All right. So in activity 1, I want you to, it says here for inequalities, study each inequality assigned to your group. Not doing groups, so just look at each one of these inequalities. Work with a partner, pause. See if you can graph the equation, graph the relation, determine the side that would have the solution, and shade that side like I did in the last lesson. Shade the side that would have the solution. So if you pause here, I'm going to go over each one of them. So try them first. So hopefully you've tried these. So when you're looking at graphing these, lots of different ways you can think about it. First, you want to not worry about the inequality. So we just want to know, when does x equal y? What's the graph of x equals y? And x equals y, if you think about it, are all the points where x and y are the same. 0, 0, 1, 1, 2, 2, -5, -5, -8, -8. When does x equal y? It's the same as y equals x. So it's 0, 0, 1, 1, 2, 2, 3, 3. It's all these points where the x and the y are equal. And it's also -1, -1, -2, -7 going back the other way. So x equals y are all those points on that line. So there's the line. So now we want to know when is the x, so which side is the x greater than the y? So if I just take a point that's on one side or the other, this point, the x is 6, the y is 0, is x greater than y? And it is. 6 is greater than 0. So if I took this point, that's 9, 5. 9, 5. Is the x greater than y? Yes. Even if I took, let's say, this point down here, I'm still on the same side of the line. That would be -3, -7. -3, -7. And be careful when you're dealing with negatives. Yes, -3 is greater than -7. It's closer to 0. So if you know it's the points on this side, that's the side you're going to shade with all of the solutions. So maybe shade with. So this is the side that works. Any point on this side of the line will satisfy that inequality where x is greater than y. Any point on that line would satisfy x equals y. All right, let's look at the next one. This one you just have, and again, if we just had -2y equals -4, forget the inequality, and you solved it, you divide by -2. Let's divide by -2. You get y equals 2. Well, if you remember, y equals 2 is the horizontal line going through 2 on the y-axis. So this is y equals 2. Well, the easiest points to pick, -2y, -4. The easiest point to pick if the line doesn't go through it. The last one went right through 0, 0. If it doesn't, use that point as your reference point to see, should I shade above this line or should I be shading below this line? So if I use 0, 0, that means the y is 0, so -2 times 0. Nothing to do with the -4, nothing to plug in. 0, -4. The question is that greater than, right? Is this greater than? Is 0 greater than -4? And it is. 0 is greater than any negative. So this is the right place. Any point below that line, so even if I took this point over here, really all that matters is the y, that's -5. So if I do -2 times -5, is that greater than -4? Negative times negative is 10. Is 10 greater than -4? Yes. So we would shade where the solution is. Everything below the line is a solution to that inequality. So the next one, if we take just the equation part, 3x equals 0, divide by 3, divide by 3, x equals 0. A lot of people have trouble graphing x equals 0. Well, x equals 0 is right here and every point on the y-axis. X equals is a vertical line, x equals 0 is the y-axis. So this one actually goes through 0, 0. So I have to pick one side or the other. Let's just pick this side where x is 4. So is 3 times 4 less than 0. Multiply, is 12 less than 0? No, so I picked the wrong side. So don't check that side. If you want to make sure, check this side. Say negative 6. 3 times negative 6 less than 0. Is negative 18 less than 0? Yes, that's the right side. That's the correct side. So make sure you shade. So everything on this side of the line and on the line would be part of that solution. And again, if you're not ready to change, just pause. All right, then the last one, x plus y equals 10. We could do the intercepts like I did the last time. So if I forget the y part, x would equal 10. If you forget the x part, y would equal 10. That means 10 for the x, right? 10 and 0 add up to 10. 0 and 10 add to 10. And every point in between, right? 9 and 1, 8 and 2, 7 and 3, 6 and 4, 5 and 5, 4 and 6, 3 and 7, 2 and 8, 1 and 9. All of these add up to 10. So now it doesn't go through the origin, so I'm going to try 0, 0. Is that greater than 10? So here I'm doing the equal to part to get the line. Here I'm doing the inequality to see where I'm going to shade. So if I plug in 0 and 0, that's not greater than 10. So it's not on this side of the line, so the shading must be on this side, up here. Everything up here would give you a pair of numbers that's greater than 10. All right, so look at activity 2, next page. Here's a graph that represents x minus y as 5. So here's x minus y equals 5. So sketch the inequality. So here is that represents these inequalities. So in this one, it's no longer or equal to like this one. It's only less than 5. So if we don't want it to equal to, we don't have the or equal to, this solid line is going to become a dotted or a dashed line. It's not solid anymore because that line wouldn't work. Like here, everything on this line is a pair that when you subtract them, it equals 5. Well, we don't have the or equal to, but so we need to just see which side of the dotted line we're going to shade. And again, 0, 0 is a good point to pick because it's not right on the line. So is 0 minus 0 less than 5? Is 0 less than 5? Yes. So this one will be shaded on that side of the line where the 0, 0 is. This x minus 5 is greater than or equal to. It does have the or equal to, so that one would stay a solid line. If we did 0, 0 again, is 0 minus 0 greater than 5? Well, 0 minus 0 is 0. 0 is not greater than 5, so this is on the wrong side. So which side would I shade? The other side. Since that didn't work at 0, 0, shade the other side. So for this one, the solution's down here, but it's a solid line because it has that or equal to. It has the or equal to right there, meaning it's a solid line. This one didn't have that or equal to, so it's a dotted line. So looking at part 2, is this going to be an or equal to or not an or equal to? Right? It's not going to have that or equal to because it's that dotted line. So it wants us to write an inequality for this one. Well, this line is usually y equals x. It goes straight, diagonal, 1, 1, 2, 2, 3, 3. But it's not y equals x because it can't be equal to. It's shaded up here. So up here, is this where the y is greater than the x's or where the y is less than the x's? So if we take a point that's in the shaded region, y is 6, x is 0, so we say it's greater than. 6 is greater than 0. Up here, the y's are greater than the x's. So our inequality would be that y is greater than x. Write the inequality. All right, that was a very short lesson. Go ahead and try the assigned practice problems to go with that lesson and have a great day.